Hi, today we're going to be learning about the effect that changing the dimensions of objects has on their volume. We're going to start off by doing an investigation where we're going to be looking at what happens when we double the dimensions of 3D objects. In this investigation, you're going to take this object that I've given you over here and you're going to work out the volume and put that volume in over here. Then once you've done that, you're going to work out the volume if you double one of the dimensions of this object. You work out the volume, and then over here you need to write down what the relationship is between the original shape's volume and the volume that you just worked out. Then you're going to work out the volume if you double two of the dimensions. You work out that volume, write it here, and you're going to do the same thing again, writing down the relationship between the original shape's volume and this new volume over here. And then you do the same thing for if you double all three of the dimensions. I'm going to give you 1 minute to do all of that. Okay, so let's take a look at what you should have got. So you should have found, first of all, when you found the volume of the shape that you were given, that it was 1,000 meters cubed. Remember, when you're working out the volume of a prism, you work out the area of the base and you multiply it by the height. But when it's a cube like this, it actually is just 10 times 10 times 10. You're going to be multiplying all three of them together, and because it's a cube, they're all the same. So it's 10 times 10 times 10, that's 1,000 meters cubed. Next, you have to work out what the volume would be if you double one of the dimensions. So it's going to be something like this, where I've stretched it, so it's going to be double in length like that. Okay, so now I'm going to have 20 times 10 times 10, and that gives us 2,000 meters cubed. The relationship between the original shape's volume and this volume is that I multiply by 2. Okay, now if I double two of the dimensions, it'll look something like this. So I have double the length and double the height over here. And when I work out that volume, is going to be 20 times 20 times 10, and that gives me 4,000 meters cubed. The relationship between the original and this is I multiply by 4. And then if I double all three dimensions, it's going to look something like this. So I've got 20 times 20 times 20, and that gives me 8,000 meters cubed. And the relationship between the original volume and the new volume is that I have to multiply by 8. Okay, now you're going to do the same thing for this next object. I'm going to give you 1 minute for this one as well. Okay, so let's go through what you should have got. So first of all, when you work out the volume of the original shape that you were given, you should have found if you multiply 5 by 4 by 3, you should get 60 centimeters cubed. Then when we double one of the dimensions, we're going to have over here 10 by 4 by 3, That gives us 120 centimeters cubed, which has a relationship to the original one where we multiplied by 2. If I double two dimensions, it'll look something like this, and you're going to have 10 by 4 by 6 over there. So that's going to be 240 centimeters cubed, which if I take the original shape, I need to multiply by 4 to get that. And then for the last one, we double all three dimensions. You'll end up with something like this. So now I have 10 by 8 by 6, and that gives us a volume of 480 centimeters cubed, which if we look at the relationship to the original shape, I have to multiply by 8 to get this new volume. Okay, so now let's go and have a look at the patterns that you should have seen emerging when we did this activity. So when we double any or all of the dimensions of a 3D object, the volume is going to be affected, okay? So first of all, if you double one dimension, we found that the volume will also be doubled, okay? We had to multiply by 2 to get the new volume. If you double two dimensions, then the volume is multiplied by 4, which is the same as doubling twice. You double once for each of the dimensions that was doubled. And then if you double three dimensions, then the volume is multiplied by 8, which is the same as doubling 3 times. Once for each of the dimensions that was doubled. So you multiply by 2, you multiply by 2, and you multiply by 2 again. And that's the same as multiplying by 8. Okay, so now we're going to go and have a look at an example where we're going to apply this knowledge. So in this question, you've been told that the volume of a rectangular prism is 75 centimeters cubed. And we have to work out what its volume will be if its length is doubled, if its length and breadth are doubled, and if its length, breadth, and height are all doubled. Okay, I'm going to give you 1 minute to work out all three of those. Okay, so let's go through that question and see what you should have got. Right, so first of all, we're working with a rectangular prism that has an initial volume of 75 centimeters cubed. Okay, so I'm going to be working from that 75. The first question is, what will the volume be if its length is doubled? So the length is only one dimension. So remember, we multiply by 2 for each dimension that is doubled. Okay, so I'm going to take the 75 and I'm going to multiply by 2 because the length has been doubled. And that gives me a new volume of 150 centimeters cubed. So that's what you should get for question A, that the new volume will be 150 if just the length is doubled. Then question B, if the length and breadth are doubled. Now, in this case, 2 dimensions are being doubled. That means that I have to multiply by 2 twice, which is the same as multiplying by 4. So I've got 75 times 4, or you can say times 2 times 2, or you can say times 2 squared. Okay, and that gives me 300 centimeters cubed. And then the last question is, what will the volume be if its length, breadth, and height are all doubled? So I've got 75 that I'm starting with, and now I'm doubling for the length, and then I'm doubling again for the breadth, and I'm doubling again for the height. So this time I'm multiplying by 2 times 2 times 2, or I'm multiplying by 2 cubed, or I'm multiplying by 8, which is the same as 2 cubed. Okay, so you can do it any one of those three ways. You can write times 2 times 2 times 2, where you're multiplying for each of the dimensions that's been doubled, or you can write times 2 cubed, where the cube tells you how many dimensions are being doubled, and you can also write it like this, 75 times 8, and that should give you a volume of 600 centimeters cubed. Okay, so let's go on to the last question for today. Very similar, but you need to think a little bit more carefully about this one, because this time you're working with a cylinder. Okay, so this time you're told that a cylinder has a volume of 90 centimeters cubed, and we need to work out its volume if its radius is doubled. We need to work out the volume if its height is doubled, and we need to work out the volume if its radius and height are both doubled. I'm going to give you 1 minute for this question as well. Okay, so let's go through that question and see what you should have got. Right, now like I said, you have to think a little bit more carefully about this one because you're working with a cylinder. Okay, so first question was, what will the volume be if its radius is doubled? Now you need to remember that with a cylinder, the base shape is a circle. Now if I take the radius and I double it, then the whole circle is going to end up bigger. It doesn't just get doubled in one direction like this. It doesn't just go like this. It gets doubled in both directions like that and like that. So when you double the radius, it's actually the same as doubling 2 dimensions because it's being doubled in both directions. Otherwise, it's not going to be a circle anymore. Okay, and the radius is being doubled. That means the whole circle is going to get bigger by that factor. So when you're doing the radius for a cylinder, it's the same as doing 2 dimensions. So you have to be careful about that. Okay, so for question A, we are doubling the radius. So that's 2 dimensions that's been doubled. Okay, so I have got 90, and I'm multiplying by 2 for 2 dimensions. So it's times 2 times 2, or times 4, or times 2 squared. Okay, so that's going to be times 4, and that gives us 360 centimeters cubed. So that's what we should get for question A. Right, then what is the volume going to be if the height is doubled? Now the height is just normal. So the height is just 1 dimension, so I'm going to be multiplying by 2 once for the 1 dimension. So I've got 90 times 2, and that gives me 180 centimeters cubed for question B. And then question C, what will the volume be if the radius and the height are both doubled? So now remember, the radius is the same as 2 dimensions, as I showed you over here, okay? And the height is then a 3rd dimension. So the whole thing is being doubled. The radius is being doubled in both directions, okay? And the height is being doubled, so it's going to be times 2 times 2 times 2. It's 3 2's because I'm doubling 3 dimensions. Okay, so I've got 90 times 8, because that's 2 cubed, or 2 times 2 times 2, that's 8. And that gives us 720 centimeters cubed. So that's what you should have got for question C. And that's what happens to the volume when we double the dimension of an object. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.